Good evening, students. Today I am going to teach you the second chapter of your university, that is your motion in a straight line. It is actually your third chapter, motion in a straight line. So the chapter name is motion in a straight line. So before going into this chapter, let us understand what is the concept of motion. See, the branch of physics in which the motion is studied, motion of the objects is being studied, is called your mechanics. So motion, it belongs to a branch of physics that is called your mechanics. Got? Again, this mechanics is further classified, means depending on the size of the object, the world of the object and the speed of the object. This mechanics is divided into three categories. What is that? The mechanics that what we are using in our day-to-day life, that kind of mechanics is called classical mechanics or Newtonian mechanics. Newtonian mechanics. Microscopic world, the mechanics of the microscopic world and the macroscopic world, what we are dealing, they are different. The laws here cannot be applicable there. That's why the microscopic world, whatever mechanics is being studied, that is a separate branch, and the laws are something different from here. And as the world is different, that mechanics is called your quantum mechanics. What? There is also a class of mechanics that deals with, see, in our day-to-day life, if you consider the motion of a car, motion of an aeroplane, motion of a train, they are actually comparable the speed we are using them, but they are not comparable with the speed at which the light travels. Got? So there is a class of mechanics in this basing on the speed that is related to us directly. We are involved. They are coming under your classical or Newtonian mechanics. But the speed, if there is speed of the object, it is comparable to that of the light, then the branch, these branches particularly will be sufficient to explain the concept, because some observations will change there, and that mechanics is called your relativistic mechanics. Relativistic mechanics. Don't worry, students, these two are not in our syllabus. We will focus on the classical or Newtonian mechanics. Got? There are also a very separate kind of mechanics for the gases and particles, that is called your statistical mechanics, but that is beyond our scope. Only we will concentrate our study to your classical or Newtonian mechanics, which is there in your syllabus. So let us, if I am dealing mechanics, means you consider I am teaching you classical or Newtonian mechanics. So here this mechanics means classical mechanics you refer now. Again, this mechanics also classified into two branches. One branch is called kinematics and the second branch is called dynamics. Kinematics and dynamics. The basic difference is, in kinematics we will study the motion, only motion. But if someone will ask questions, why the motion is there? Why the motion is there? Means to find out the reason behind the motion. What causes the motion of an object? Why the object is in motion? Clear? Why the object, the speed of an object increases? That thing we won't study here. Means we will study the terminology related to the motions and the motion itself. Here, kinematics is actually the study of motion without knowing the cause, without the cause of motion. Yes. Now here it is actually the study of effect. Now dynamics is what? It is the study of motion, the study of motion along with the cause. That is called your dynamics. Clear? So before going into motion, this idea you must possess. That's why I discussed. Now come, what is the meaning of a motion? What is the meaning of a motion? Suppose if I'll ask a question to any one of you, suppose my question is whether here I am at rest or I am in motion. A person said, you are at rest, I am at rest. And a person said, I am in motion. Then which of the two person is correct? The answer is actually both of them are correct, or both of them can be wrong. How? See, simply asking the state of motion or state of rest of an object is meaningless. How? If a person will say, yes, I am at rest with respect to the board here, with respect to the board, with respect to this wall of this room, I am at rest. Then the person who is saying that I am at rest means with respect to the person which is also at rest with respect to me, he is correct. And the person who said I am in motion, he might be outside the earth, because the earth is rotating. The person is here. If the earth is rotating, the person is here. It means if you put a mark over here, let us put a dot mark over here, which is me, and the person is here, earth is rotating means what? With respect to that person, the person is moving. You see the dot mark is that side. So it means motion, the concept of motion and rest, it is actually a relative one. Clear? So to define motion, it's not easy. Means actually whatever motion we are dealing with, yes, that is with reference to something. So to define motion or a state of rest, we need to know a reference point or reference frame to define the motion. Clear? So to define a motion, we must know reference frame or reference point. We must know it. The reference point. Clear? What is that? Again, suppose you have a room with you, and let's say these are the three edges of your room. You can say this is a point where all the three edges coincide. This is your horizontal, means this is your plane of the room, and this is in the direction of vertical. Yes? Suppose this is your horizon, means, or we can say, like, we can take, it will be your x-axis, y-axis, and this will be your z-axis. So if you take the room where you are, the three corners, let's say this is one corner, there is a corner, this axis and this axis and this axis, it can be your reference frame. Suppose there is an object here. So actually I am explaining what is a reference frame. Usually your x, y, z axis or coordinate system can be treated as a reference frame. you place a clock at the horizon. Clock will measure the time, because without measuring time, motion is what? Meaningless. So to measure the time, we can place a clock over here. The clock is fixed with the axis. Means reference frame means 3 coordinates x, y and z along with a clock to measure the time. That is your reference frame. This point is called your reference point. Clear? So this x, y and z axis you can fix anywhere according to your choice. Suppose there is a point P. There is a point P here whose coordinates at a particular instant of time is x1, y1, z1. Let's say the time there it is t1. Suppose someone is marking, the person which is observing the motion here, he sees the position of the object at different time instants. If the position of the object P is fixed, means the coordinates are fixed, but this time coordinate will change, then we can say the object is at rest. Clear? The x, y and z, they are called position coordinates. This t refers to your time coordinates. Remember, if the position coordinates is fixed but the time coordinate changes with time, then the object is said to be at rest. Clear? But if along with the time coordinates any one of the position coordinate changes, then we can say the object is in motion. This is the simple definition. Clear? If the position changes, means suppose the object at a particular time instant it is here. If at some later instant the position will be x1, y1 and z1, x1, y1 and z1, then we can say the object is at rest. If the position changes, means the coordinate changes. So the position here it will be, let's say that P1, which is x2, y2, z2, and the time will be definitely t2. Remember, the time coordinates always changes, but the position coordinate may change or may not change. If the position and time coordinates changes simultaneously, then the object is in motion. If with the time the position coordinate won't change, then the object is at rest. So this is the basic concept of your rest and motion. Thank you.